This live discussion and Q&A for August 19th or September 16th, 2015. I'm Russell Alleen-Willems of Diachronic Design, and tonight I'll be interviewing Brian Ballsun-Stanton of the FedArc organization about their FAIMS archaeology data collection and management system. Hi, Brian.
Hello, how are you?
Pretty well this evening, and it's actually tomorrow about mid-afternoon your time, I believe.
Yes, so hello from the future. The future is rainy.
We'll keep that in mind. So, Brian, we brought you here tonight to talk about some of the abilities of the FAIMS database, but also how to use this system and how to think about the database structure and how to best use that as we go forward, kind of transitioning from paper forms into something that takes advantage of all the things that are on a tablet computer and things like network synchronization to synchronize our databases from across many different users. Before we get too deep into database theory or some of the other things we'd like to talk about tonight, could you maybe list out some of the basic terms that if someone's not familiar with databases in general, that would be useful to know?
So some of the basic terms here that we're talking about, tables. So when I say table, the best way to think of a table is as a Excel sheet, right? So a table is going to have row and columns. The columns are going to have very constrained domains, and the rows are going to be instances of those domains. When I start getting fairly technical on the database side, I may swap over into the more theoretical vocabulary. So I may be using the word relation for table, which is not to be confused for relationship. I will try to avoid that, but when we start talking about normalization, the language swaps over. And so that's definitely one of the major vocabulary terms that confuses about 104% of people. Some people just stay confused. The FAIMS terminology, at the end of the day, is abstracted to a far greater degree, which means that it's far more simple and far more complex. The main thing to be concerned about here is the archent, or archaeological entity. Now, I kind of regret naming it an archent because what we found is that FAIMS is a lot more general to field data collection than simple archaeology. And so an archent, despite being called an archaeological entity, is in fact an entity which holds data collected in the field. And then, of course, there's relationships which can serve to relate these entities. I'll also be talking about attributes. An attribute is another name for a column. Okay. And I'll be talking about controlled vocabularies. Now, the idea of a controlled vocabulary is that what should be at once intimately familiar and quite strange to normal database people, because normal database people are used to lookup tables, where the table holds a key, is named after its vocabulary item, and the values in that table correspond to the vocabulary. Because FAIMS is far more abstract, we have a single table which holds all vocabularies. And so there's definitely some nuance as a choice of my denormalization. There's another word, denormalization. So just as the act of making a database more perfect, TM, is normalization, and the way normalization can very quickly be thought about is as a way of avoiding anomalies. So ensuring that data in the database appears once and only once, and when it appears, it's authoritative. And so normalization is the process of structuring a database such that it can be thought of as an authoritative source. Denormalization is breaking those rules intentionally to achieve other objectives.
Okay, so here, people that might be familiar with the relational database might know that one of the differences between a spreadsheet and a database is wanting to normalize your data, kind of break it into its component parts so that you're only recording one thing in each row, essentially. So you won't have repeating values. Like, for instance, if you were listing all the recorders for a particular site or a particular feature, you would break that out into its own table of people that worked on this site so that you don't have to retype someone's name, which can lead to issues like typos showing up, or, as you said, with controlled vocabularies, having a lookup table where you would have the particular names for different types of artifacts. So you won't have two different people writing down different terms, or you won't have two different people spelling things slightly different, such as working with people that spell things in the British way and people that spell things in the American way.
And people who spell things in the Australian way.
Which is its own kettle of fish, I imagine.
Always fun. Precisely. And so the exigencies of the situation, databases are designed for a central server so that the clients are always talking to the server and the data exists in that server, and that server has the true data, and any changes to it must go through the server. Because we need to support offline interactions, we don't have that luxury. And so that's put a number of design constraints that we're going to talk about in that are challenging and more to the point, confronting to people used to normal databases.
So it sounds like you and the rest of the FedArc team have looked at kind of the specific needs of field sciences. And like you mentioned before, not just archaeology, but geology, biology, some of the other people that work in similar conditions as field archaeologists. Before we get a little bit more into how FAIMS was designed, could you actually describe what FAIMS is? Because I know there's sometimes a misconception that there's a shiny Android application, but that's just one piece of this system.
The FAIMS project is designed to providing field sciences and field humanities support across the entire life cycle. So data can be born digital. It then goes into various online processing systems and ends up into a repository. And the FAIMS project is responsible for all stages of that life cycle. We have a number of partners, Hurist and TDAR, that supply the major tools used in other parts of that life cycle. And so because we haven't had to develop from scratch, and most of our development time has been spent in creating the field collection workflow. Now, the field collection workflow is not only an app. Instead, it is a paired instance of the Android application, and it's Android only. It's native Android, and due to the requirements for various maps and whatnot, we cannot support Apple at this time. If you have a couple $1 million, let us know. But the app alone does not the FAIMS mobile platform make. We also have a server which is designed to synchronize or collate, if you would, the records collected by individual Android applications or individual instances of the Android application collecting data for a particular module. There's another word, module. A module is a set of definition files designed to support a specific field methodology, data collection methodology. So the whatever you're trying to collect will be supported by a data schema, a UI schema, and some logic, as well as other files, to allow you to accomplish your research goal. And so by coordinating this research effort through a dedicated server, which usually isn't in the cloud, we've found that the cloud is quite unreliable when you have no internet access.
Yes.
By definition. So when you have this server and the Android tablet, they're designed to coordinate together to allow multiple devices independently while offline to collect highly specific and individualized relational, well-formed field data, which can then be immediately ingested into a database or other analysis system of your choice.
Okay, so let me see if I have this straight, and maybe you can correct me on some points. FAIMS is designed to kind of be a soup to nuts data management system for field archaeological data, in that people will go out as many different members of the crew, collect data on the Android devices, but because of some things that you're doing with unique identifiers, each person won't really have to worry as much about stepping over people's toes and recording the same data and then merging that all together. That this server that you're running probably on a laptop out in the field, or merging when you get back to a lab or field office, is then collating all those records together, flagging anything that's duplicated and saying, hey, a human needs to take a look and decide what attributes in your terminology to keep. And then from there, you're able to put it into a tool like Curist for data analysis, or put it onto spreadsheets to share data, or with the eventual point being getting into a repository like TDAR or FAIMS implementation of TDAR, so that then this data can be archived digitally, maintained for the long term, and also cited in reports, publications, and reused by other researchers, such as grad students working on a project, something that makes the data live on past just this one collection use.
That is absolutely our intention. The details, that is absolutely our intention, is what I'm going to say here.
Okay.
With regards to uniqueness, because this is a technical chat, I'm going to try to be accurate rather than brief. Uniqueness is a function of two physical attributes. And so the challenge in this system is how do I create a database that remains coherent and consistent while it's being written to in multiple different places without those places interacting until sometime in the future? And the answer is because uniqueness can be guaranteed by two attributes of the physical environment. The two attributes are time and person, which is a problem when people haven't set their clocks correctly, and it's a problem when people haven't, or when people reuse the same user. Those are the two primary commandments of FAIMS: is get your clocks correct, and everyone must log in as their own user. And the reason why they are the two commandments of FAIMS is because they are the guarantors of uniqueness. We basically take the FAIMS we take the user ID, and we support up to 99,999 users, which is actually a very small number. It means that we're doing field studies. It means that we're not doing major data collection projects. And the reason why we have to do it is because we run into integer limits if we went over larger. And we then combine that with the Unix epoch, epoch, resolved down to the millisecond level. So your records will be unique and won't travel in time if everyone logs in as themselves and has an account as themselves, and all of the clocks are updated from a local NTP server, or otherwise have a pretty good assurance of being the same time within about a second or two. The problem comes when you have one laptop that's engaged in or one tablet that's engaged in time travel. Really weird things start happening because what we expect to happen doesn't actually happen, because the information from the future clobbers the information from the present.
Okay, so that might be something that is a change from archaeologists that are used to, say, using the same form and passing off, say, crew chief starts it and has to wander off somewhere. That one of the aspects of this new methodology would be to go out and literally check to make sure the clocks on all the devices are synchronized at the start of the day, and then make sure when passing off that people log into their correct user account so you can track what that person did.
So start of the field season. Generally, Android devices won't drift that much, so long as they have a good starting point. And again, we're not really worried about standard 2 drift. It's important to emphasize that while we do support collaborative sharing of records, we aren't Google Drive. As much as some of the digs that I had to support in the last 2 months wished we were. Live editing by different tablets of the same records is possible but problematic, because that's not what I solved for. I solved for seriously asynchronous editing by multiple tablets, not live synchronous editing by multiple tablets. And so it's a different network environment. It's a different redundancy environment. Don't expect.
I was going to say, it sounds like this is built for.
Your camera's going off.
Yeah, I adjusted the bandwidth a little bit so that video was stuttering a little bit. So I dropped the HD a little bit. So that kind of leads into the next question about talking what is FAIMS. Could you tell us a little bit about how FAIMS was designed? I understand there were at least one, if not a couple, workshops, and then some more extensive field testing with archaeologists and other field crews in terms of trying to figure out what people needed, what was useful, and what was not.
The FAIMS platform grew out of the stock-taking workshop. It grew out of the fact that the archaeologists who attended the stock-taking workshop could fundamentally find no areas whatsoever of consensus, which isn't a problem. This is how the field works.
Yeah, we need 2 archaeologists. You'll get at least 4 opinions.
On a good day. The trick there, then, is that when I sat down to the requirements, I basically had to solve for a more general case, then solve for a more general case, then solve for an even more general case, until I could solve for the most general case possible, which is where we are today. And so quite a lot of fiddling is required to implement the specifics, because the system is designed to solve for the general case. Was that your question? No, it wasn't your question.
No, that was in terms of one of the things you had mentioned was you had chosen not to go with the typical relational database model because you needed to abstract it in such a way that it was more flexible, that it allowed 2 differing archaeologists to come up with schema that then at a higher level could work together, or at least be somewhat interoperable.
So the two major constraints that went into the database were that we could not expect archaeologists to write a fully normalized database. And so we had to offer some system that could accept a notional data structure that an archaeologist could articulate and be able to interact with that notional data structure. And so we've gone with a domain key normal form or an attribute key value data store. The attribute key value data store is a more accurate description than DKNF, where instead of having one table for one relation, see, there it is, one table for one topical domain, we have a table which holds all of the column names, and we have a table that holds all of the identifiers, and then we have a table that says for this attribute and for this identifier, here are the set of values for that attribute identifier. And the other major design input was that we needed asynchronous syncing. And so I went with an append-only data store, which now offers the really handy undo history, because the append-only data store has exactly one interaction, and that interaction is the insert. Well, to select an insert. And so to delete something, we insert a record saying this record was deleted. To update something, we insert a record with a new value. To insert something, we insert a record. And so this makes multiple databases being able to operate independently and then synchronize, because the unique properties are external to those databases, user and time.
So that's sort of your error checking in terms of you've got all these people that might be working on the same project, the same database, but they're working without being able to have their devices talk to each other. Whereas, you know, I've looked at a number of mobile databases, FileMaker Go as an example, that is typically used in field situations, but ones that have cell connectivity or internet connectivity, either in an office, or if it's remote, it's something like a CRM, not cultural resource management, but like customer relation management, where a salesperson is going out making changes that either they're the only one working with that, or they're working in a networked environment where those changes are being fed back to a server that then is synchronizing those as they work.
Yes.
But in our case, we're not working with network connectivity all the time.
Precisely. And let me say that that environment offers quite a lot of environments. It is orders of magnitude faster. It is orders of magnitude smaller. And when you have the luxury of continuous guaranteed network access, all sorts of things become possible. The problem is that our system has no problem with the idea of going off for 2 months, collecting data, and coming back and syncing, and there will be no problem. There will be no, oh, this data is out of date. We can't possibly accept this data. Because we cannot rely on any sort of synchronization interval, the main compromise we had to make was with performance. The performance of our database could be a lot better. Well, see, that's not true. The performance of our database in a highly networked environment could be a lot better. The performance of all other databases in our environment isn't. And so that's what we chose, that we chose to support this harsh networking regime with these trade-offs.
Because you were designing for the context of, we're going to assume most of the time you're not going to be working with network connectivity.
Precisely.
So you chose to optimize for that situation rather than try to adopt everything and outperform the people that were used to working in a fully networked environment.
Precisely.
So if you were talking to an archaeologist who was used to maybe doing some digital collection, in CRM I've seen in the past some use of Toshiba Toughbooks and other things out in the field where one person might have a laptop, but not adopt it all that much because it's hard to use in the sun, it's hard to use in the wet, or it's hard to use in the field environment. And typically it was so expensive that only one person, usually the crew chief, would be able to operate it. If someone were used to doing digital recording but using something like a spreadsheet, what are the advantages of using the FAIMS system over using a digital spreadsheet?
Excel and Access generally support up to one user. I believe, especially with Access, the optimum user count for Access is 0. Anything beyond 0, you get some dodgy interactions. But seriously, if you're using Excel or in the field, you have one person interacting with the database. You have one person interacting with the database, and that means that you have one person who has the thankless job of data entry. And so because the data isn't born digital, you don't have any of the benefits of born digital data. You don't have the integrated cameras, the integrated audio, video, voice transcription. You don't have the controlled vocabularies. You have, when you have data being born in an analog format, and so you have the transcription problem. And the problem is that most people don't budget or don't estimate the transcription problem as part of their budgets, and they don't value the time or that transcription and checking the transcribed documents and following up on what did you mean by this squiggle means. And so the true benefit of FAIMS is that no transcription is required. The data can, in fact, be born digitally in as many people or as many field teams as you have. And there is an incredible efficiency there at the cost of a far greater design cycle during the stressful period where you are prepping for your project.
Yeah, and that's something I've noticed with several of the digital systems, is that there's a little bit more setup time. You sometimes have to retrain crews, but because of some of the error checking that happens automatically, and largely because you're skipping a lot of the transcription, and instead of moving on to things like a little bit of error correction, looking at your data, that's actually a vast amount of time that people are usually spent, especially in a CRM context, as billable hours, sitting there transcribing data, doing things that you're essentially able to skip by just migrating that database over, doing things Absolutely. Like mail merges into standardized forms or report templates.
Absolutely.
Yeah, and it makes it a lot easier to share in terms of, hey, sometimes not everything gets digitized. Sometimes field notebooks that have a lot of qualitative data won't end up in a digital format that can be easily shared. It's literally, in the file cabinet marked "Beware of the Leopard in the Dark Basement," and never to be seen again. With that in mind, we actually got a question from an archaeologist, Chris Cameron, who was asking about questions about how specifically digital pays for itself. If he's making that sale to a business manager at a CRM firm, this is one area where there's a little bit of cost savings, even if there is a little bit more upfront setup. Could you speak maybe to some of that issue?
So I'm the technical manager, the technical guy on the FAIMS project. It would be remiss for me to say that digital always pays for itself. Digital scales better. Digital scales better. And so where digital excels is when you have multiple people needing to coordinate, or you have a large project. So large in time or scope or size or space or anywhere that large could be applied. If it is applied, then you should consider digital. If you're just giving an exploratory go and you're not quite sure that there's anything to collect, or you're not quite sure what you're collecting, or if you don't quite have methodology, don't go digital. Really, don't go digital. The digital systems offer, in that instance, a false specificity. because what they are recording is what you thought that you should be recording, not what you've discovered that you should be recording. And that distinction is important. With that said, once you're past the exploratory stage, or you have tools that can very, very quickly iterate and build tools for that exploratory stage, digital scales, the cost per record is significantly lower in the digital sense. And so it is that trend line where the true advantages lie. And the moment that you have more than one person then recording data, then you really start getting advantages because of all the coordination costs of the analog system.
So this might be an example for Chris or anybody else working in a CRM context where if you're doing a couple small surveys, it might be not worth the time to set up a digital form or a digital module. But in the case of where you're going to do a large excavation, you have a lot of people working on site, or if you're doing those small surveys and they're similar in type and you're doing very many of them, then that might be the case where you want to put the time in to build this tool because it'll be repeatable. And once that initial cost is done, each additional record you create is going to be very low cost. And essentially, each new one you make will bring the cost per form or per record down each time you create a new one.
Absolutely. And I think that we're getting on a bit. So what I want to give people a very quick tour of the script that provides for our database. And just, I think that this tour will be a way of providing more questions to be asked. So I'm going to screen share, and Great. I'm going to hope that this works.
And so Brian, this is one of the scripts that you have that kind of acts as a way to ease the transition into making a FAIMS module.
Actually, this is
something
else. True database. Okay. This is the SQL that instantiates database that runs FAIMS. And so we have many layers of translation between this script and the user. But it's important to realize that, yes, there's SQL at the end of the day. And so because part of this, I want to be, part of the audience for this is people, so I'm clicking over to the showcase now, and there is the cookbook and there's the user to developer documentation. Part of the challenge with the cookbook and the user to developer documentation is writing queries for this database, because honestly, queries for this database are seriously not fun.
Yeah.
Oh dear, is this formatted? And if we look behind the curtain, I need a different.
So this structured query language, or SQL, is what's actually being used to create the different tables you talked about, like the ArcInt table, an internationalization table, such as translating between different terms or different languages. Is that correct?
So this is one of the fundamental files, right? Mm-hmm. The other fundamental file is the arc16n. The arc16n, and I'm just going to pull one from Cyro, is a key value pair. And so this key value pair allows us to take items presented in the UI schema, right? So we have the key take photo, and then it's rendered here. Now, obviously, this is a trivial one, but we then have one right down here, which is where we have a code, tal, which is rendered for the user as alluvium. But in the database, it is one of the geological terms. And so because we can present different key values, we have we don't need to show codes to users as they're entering. We can show the long forms. And so this data scheme, this lookup table is written into the vocabulary table attached to a specific attribute. And so this database, we have a list of users. We have a list of entities with their name and some human descriptions. We have a list of attributes that have names and descriptions and format strings. And so the reason why we have format strings is because we can actually apply formatting rules to the attributes to do some fairly nuanced display rendering output tweaks. We have vocabularies, and we support semantic maps. We support picture galleries. And then we have specific instances of the entity. And so we store geospatial data with the entity at the entity level. So the true geospatial data is stored at the entity level. And you can see here that we have the UUID and timestamp and user ID. And this forms the primary key.
And as you can see there, the UUID has a timestamp and the user ID also attached to it. So that's that composite key you were talking about.
Precisely. So we create a synthetic key of guaranteed uniqueness smooshed into the field called UUID. Then we take the time and we write that into the timestamp. And through the timestamp, we get the R append-only nature. And so then we have values. And the next cool thing about FAIMS is that instead of storing a singular value, we store 4. And so a single attribute can have a constrained, can have 0 or more constrained vocabularies, unconstrained data, annotations, and certainties. And so these terms are relics of the internals. In the server, you'll see this as constrained data, unconstrained data, annotation, and certainty. Certainty varies between 0 and 1 and reflects the user's confidence in the data. Annotation is the scribbling in the margins, this is not data, this is discussion. The measure is where the professional observation of the trained archaeologist or field scientist goes, and the vocabulary is where the constrained vocabulary goes. And so another benefit of this setup is that we can handle multi-value data without too much trouble. When things have the same timestamp, exact same timestamp, and UUID in this value, they are multi-valued. And so they are displayed by the system as a multi-valued entity, but they are in the internals individual items which can individually be manipulated, which is rather a nice design, if I say so myself.
No, that is pretty neat that it's able to handle that complexity, but still render it in a way that people are used to seeing it.
With that said, all of this comes at the trade-off of performance. If I was designing a high-performance database, I would use this database as a guide of what not to do.
But again, this is a case where, recently, past 10, 15 years, there's been a lot of talk about big data. Whereas we in archaeology typically have relatively smallish databases, even if we're into hundreds of thousands or millions of records.
Yeah.
We're not doing physics or astronomy where they really do have these databases too large to fit in memory at any one time and have to do all sorts of things to manage that.
A good heuristic there, by the way, is if your big data demo can run on your laptop, it's not big data.
Nice.
Just
that's the metric.
And so what we have here are views that perform a lot of the common manipulations. And you can see that I've got layers of these views that build on previous layers of these views.
Good old SQL queries and subqueries and joins, just kind of building turtles on top of turtles all the way down.
It is
but
indeed
you're able to build something simple and then iterate until it gets more complex.
This is, so latest non-deleted arcant identifiers is one of the more important views because it shows all the identifiers for the record. And if you say latest non-deleted formatted arcant identifiers, it returns a formatted output. So this is just a very brief glance at the database. We actually have a viewer, so hello to you, oh viewer. If you go to the grid at the top right of your screen, you can go into Q&A mode and you can ask questions of us as I search around for other files to show off. And Russell, if there's any other things that you want to cover, now is a good time.
So one of the things that was asked was whenever you get your data into FAIMS and you have it in the backend database, the FAIMS server, when it comes time to get the data back out, to transform it into something you can send to colleagues or a view they might be more used to seeing, you have the data in a very abstracted database that someone working internally has that context and knows how to use it, but anyone that just wants to look at that data or query that data, what is the process like for transforming into one of those formats?
So there are a couple ways of doing this. At the end of the day, we've found that most people haven't chosen to engage with our internal data structure for some completely inconceivable reason. So instead, what we have is an exporter. Click, click. And so this exporter takes the database in and writes out CSV. And we've found that this suits the need of most people because they don't care about their data history. They don't care about the n sub attributes of any attribute. They don't care about breaking apart the multi-valued attributes. They just want their data. And so I've written an exporter that provides just that. And so it exports CSVs, shapefiles, and a more normalized database. I'm not going to say very normalized, but more normalized database for easier manipulation. It also renames all attached files and multimedia to the identifier. And this is just something I just threw in as like, well, I need to export the files and they're named garbage, so I might as well rename them. And it's actually proven to be an unexpectedly huge time saver because it means that multimedia manipulation is free. And so when you attach the data, the files during collection, or you take the pictures from the app, the pictures are already all of the necessary metadata to be usable in the research context. And I'm quite happy with that. And so we even write the row data into an EXIF into each picture so that the picture is branded. I'm not going to say indelibly branded, but you'd have to go to some effort to get rid of it with the raw data of the picture, so that even if the picture is renamed or separated from its original context, it will always be truly linked to its parent data.
That's great, because as someone that has, even with born digital data, assumedly taking digital photographs, but then not in a way that are linked to the database record, sitting there in Photoshop for hours, doing mail merges to process information from the database and the collected records and attaching it to the images is a pretty large undertaking, and something that I think a lot of people don't necessarily think about whenever they're trying to find that photograph later. If it's not in their database or somehow marked with the EXIF data, it's very hard to link that back up, and you end up with a lot of people sitting around scratching their heads saying, well, I think that's the photo of this feature, or I think this photo of this artifact. But it could be this other very similar one.
And one of my aims when designing this database is no orphaned records, no orphaned files. And so we have a number of tables in our database that are designed to manage our attached files and make sure that we don't lose any.
So that seems to be going back to Chris Cameron's question for a minute, in terms of not just the financial benefits, but in terms of being able to synchronize all this data so that they are not orphaned, so that they are attached and able to be related to. Seems to be a very powerful tool. I know Rachel Opitz at the Center for Advanced Spatial Technology at University of Arkansas, and Spark, I believe, is other organization that she's with, has talked a lot about born digital data and the ability to quickly collate that and then make interpretations on it while you're still out in the field, to actually be able to have that inform the next day's field work instead of waiting until you have to transcribe all these things, and being able to make better decisions because of it.
Absolutely. And our data lifecycle, clicking export, so long as you have an appropriately updated server, is something that takes a minute or two, and is absolutely can be part of the where do we survey tomorrow decision-making process.
And that seems to be, with all kind of the digital archaeology products, a goal towards integrating all these processes together so you can make faster decisions, you can make better decisions, you can be more efficient in collecting your data so that more does get collected and is more usable more immediately. And then on the back end, being able to be cited, being able to be shared.
Yes.
With FAIMS in particular, how have you been able to use this database with some of your demonstration projects? What has the process been for people to come on board and create a module? Because I know with the documentation we're working on, that's something we're trying to improve, is getting someone from the start of the line with essentially no or very limited database knowledge and used to paper forms into this iterative process of turning that paper form into a digital form, and then adding in the things like attached audio, video, and GIS records.
If you don't have any database knowledge, the best bet is to engage with us with your paper forms and let us iterate with you to find the digital recording solution that actually matches your model of reality and your intentions of what you want to collect at the desired richness. Otherwise, if you have a promising grad student or a promising digital archaeologist of some stripe, the documentation that Russell has written that is linked over in the showcase, the user to developer documentation, funded courteously by the Nectar project. Thanks, Nectar. It's actually been really useful. Is a good way of getting your grad students to think FAIMS. And so we're iterating, and obviously this documentation is in first steps, but with the tools that documentation gives your grad students, you can save a tremendous amount of money with your initial explorations of what should our data structures look like and what should this look like. And the modal case that we anticipate is that people are going to rough out their projects using this schema and make sure that they have someone on site who understands FAIMS to some degree, and then asks us for the final polish, the final tweaks that this bridge doesn't provide. Because yes, reading this and reading the cookbook, you could very well be a developer of FAIMS, but there's still a great deal of expertise of the mistakes of the past and how to write good queries that our documentation is built on. And so the modal interaction bimodal. The bimodal interaction we anticipate is first grad students just using this documentation to make small data collectors and running with it for free, which is great. Awesome. We love it. And the second one is established projects using this documentation to enter their own data, because it doesn't make sense to pay us for data entry, and to explore the metaphor of FAIMS. And then when they come to us, they give us this XML that we've taught them how to make, and vastly reduce their costs, vastly, because all of the TD spit's already done. And so we can do what we do best, and the true domain of our expertise and testing.
So it does seem like, as you talked about, that bimodal distribution between people that just need a solution built for them, and then on the other end, this generation of archaeologists that are coming up, knowing there are digital tools out there that can make their research better, make it faster and more efficient, and in this sense is a free tool with a little bit of a learning curve. And what we're trying to do is build documentation for both groups of, hey, here's how you can get something up quickly and running. And then here's where you maybe might want to hire somebody to do some of the database work for you. But then I know we received a comment earlier on from a graduate student that was talking about how they had just taken a relational database course, and they were looking to use FAIMS for their own research and also to get their department to learn how to use this tool in order to teach it to some of the other students. So that they go in thinking digitally, thinking about how to best use these tools out in the field. On that end, we're going to open it up for Q&A, but I'll add in questions that we have from emails and other things. Are there any things that someone coming with no database experience or no relational database experience, or rather relational database experience but different from the version that FAIMS is using, are there any mistakes that you think people might make commonly that they should avoid in this? Or how is it different thinking about how to build something for FAIMS versus using another database or using a paper form?
Nice, easy questions to start with.
Yeah. Takes me a full minute to get out. It ought to take at least a minute to answer, right? Perhaps a simpler question. Someone coming and wanting to transform.
The wheel of thinking is going. Just a second.
I'll wait for the hourglass to finish.
This isn't a relational database in the instinctive sense that people used to third normal form are used to. Trying to create lookup tables using archents is a process that, while technically possible, is not a good idea. And so there are different ways of representing databases when you're normalizing them. And this is fresh in my mind because I'm teaching one of our grad students how to database. And the Chen notation of the bubbles, before normalization, before any of that, just a representation of what you want to record and how they relate to entities, is about the right place to bring this, where you want to say, we in this tab group want to record these things, and these other things have controlled vocabularies. And then we want to record this other thing that records these things and has these controlled vocabularies. And here's how we want to relate them. And so it needs to be in the theoretical or the pre-normalized fashion. And so if you can get us the requirements in the pre-normalized fashion, it will save you effort. Mm-hmm. I mean, honestly, we can look at a normalized database and turn it into a FAIMS database with some cheering, actually, because they're few and far between. But it's an exercise that is its own effort, and the effort isn't necessarily bad because it creates a certain data quality, but it may not be. It certainly isn't necessary for FAIMS.
So as you were mentioning, talking more about how you want to collect the data, how you want to be able to use it, is maybe the better place to start versus trying to normalize this, because it's not going to work the same way in the FAIMS system. There are a series of tables, but your data is not related in the same way as in a relational database.
And so I would say that you should approach this from the UI perspective rather than the data perspective. We have a large number of wireframes that represent program flow for the database, and creating a wireframe for us will drop your costs by at least an order of magnitude, because it means that we already have the source of truth that we can implement, that we can mimic. So if you're looking to save money and time, make that wireframe. That's what I would say. Don't make the database, make the wireframe.
So literally do some of the anthropology. Think about how you collect data out in the field, what things go together in that UI, or what you might want to see on one discrete screen without scrolling, without doing anything.
After this field, this next tab has this field, this field, this field. The logical structure for us is the tab group. The tab group is the entity. It is possible but fiddly to have multiple entities in a single tab group. It's part of various deluxe packages, but not something that we can do quickly. So the way to think about it is, what is each tab group, and what information do you want to record on each tab group?
Okay, so whenever people are going out and they're maybe used to a paper form, they need to think about, hey, we can take that directly and put it in there, or we could go a step further and think about some of these things that we're capable of with the digital tool, in terms of not just the paper, but keeping track of user accounts, removing having to put initials of things. As long as you're using those user accounts, that user will be attached to the record. But then integrating things like, hey, whenever we're going out on this type of excavation, we have a lot of stone tools, we have a lot of lithic artifacts. It might be useful at this step, right before we're going to enter what type of projectile point it is with our annotation or our certainty value, to maybe have a lookup, a picture gallery that shows some of the common projectile points.
Yes, and the all of my tablets are gone. We're actually working on a module right now that has something on the close order of 700 pictures in its info boxes, so that you have 8 field manuals baked into the module, serving as contextual help for every single attribute. And it's pretty cool, I think.
That is really fantastic that you're able to have those types of resources at hand whenever you're recording, whenever you're thinking about what you're doing out in the field. And to be able to do things like, hey, I'm not 100% certain this is what it is. I want to flag this later on for our lithic specialist to take a look at. Or
Yes.
here's, better yet, that certainty value, as well as here's a picture of this specific artifact. And then here's in the wider context where it relates to what type of debitage is found nearby. What
Absolutely.
part of the site are we in?
The other thing to think about before going into FAIMS are what validation rules do you want to enforce? Because we have a incredibly sophisticated validation rule set, or a tool chain that no one uses. And the ability to do server-side validation allows for basically arbitrary rules to be enforced and flagged, or client-side validation through our logic. And this offers almost a literally unprecedented opportunity relative to paper forms, because the problem with paper forms is they can't think.
Well, and I think that's maybe a good place to end part one of this discussion, where we've talked about reasons why you might want to use this database, what type of tool it is, how it's created, and some basics on how it's laid out, what the structure is.
Yeah.
Brian, we would like to do probably a part two of this discussion, where
Absolutely.
we get into more intimate details of the database, how it's structured, and how you can maybe use some of the documentation or comment on it, what questions you'd like answered, but also start to think about how you might build up some of these modules and some of the tools that FedArc has created to ease that process.
Absolutely. And I think one of the important deciding factors of how many parts we do is how much user response will we get. If we get a lot of user response from part one, then it shows that we'll need to do more parts.
Well, I think we'll probably call it a night here for this recording. Links to some of the items that we mentioned are going to be in the show notes, and we'll attach that to the YouTube video recording of this discussion later. If you like the show and want to comment or you have questions, you can contact me at russell@diachronicdesign.com, or Brian, I believe you're Brian at fedarc.org. Is that correct?
That's one of my emails, yes.
Yes. And we'd love to incorporate some of that user feedback into the documentation we have linked. It's a work in progress, but we really do want that to be a guide that people can use to learn how to use these tools and how to think critically about what they're doing with the database structure or with the schema design.
Absolutely.
Please share this link to the show wherever you think it might be useful, among colleagues or among friends. Thanks for joining me, Brian, and I'll let you have the last word.
Well, thanks everyone for watching, and remember, the longer you can get to us before you go to the field, the better your module will be. And so on that note, goodbye.
Cheers, everyone.